Mm, Today I explain some notation. First is, this theoretic notation. A1 is in A, A2 is N in A. If everything is just A1 and A2, we write A is A1, A2. One thing is that because it is just there is something, there is no ordering, so you can write also A2, A1. Yeah. Let us think some other set. B is B1, B2, one more, B3. In this case, sometimes you want to make some relation. I write phi for later. If you say phi is some relation, such as A and B are friend or something, then you can write all the related things. For example, A1, B1. This means that A1 and B1 are related, and A2, B2, maybe A3. There is no A3. A1, B3, something like this. Okay. In this case, you can say what is related. This is how you define relation, and because it is a little bit hard to write every time or the relation, you usually use notation phi A1, B1. This means that this symbol explains this notation means that this notation means that A1, B1 is in phi. Okay, now you know one notation for the relation. Let me go second. You will meet function or mapping. Function or mapping is nothing but just there is a relation phi, same phi, but in this case there is a unique element B. So in this case you can see that A1 is related with B1, A1 is also related with B3. So in this case, for A1, related element in B is B1 and B3. So it is not unique, but if you write only A1, B1, and A2, B2, B2, in this case, for A1, there is only one element related with, I don't need this, one element, which one? B1. For A2, there is only one element, which one? B2. So you have each element of A have a unique related thingy in B. In this case, unique is important. In this case, you say it is a function or map. So the name function or map is just this one. So you write phi, and you have two different set. One is A, I write here. The other is B. But each element of A has a unique element in B. So in this case, you write this. And also, there are some little bit different meaning on A and B, because A doesn't need to be unique. It means that if you write A instead of B2, let us think this is B1. In this case, it is also unique. A1 is related with only B1. A2 is related with B2. So the set A and the set B has a different role. So phi A1 B1 is a good notation, but you can see right thing is more important than left thingy. So you can write also b1 equals phi a1. But again, this is nothing but just the same notation with phi a1 b1. This is just some more familiar. I think you are more familiar with this notation. Yeah, familiar with this notation. But in fact, this is just same meaning with this right one. So, and this is also same with this one. I hope you remember this. And finally, usually we write this, but if we want to specify what happens to this, you usually also say choose one A in here, and then this A becomes phi A. So this is some general relation. So A for this this thingy means that if you choose A1, then some element in A1, maybe I better draw a figure. So maybe you run this in your younger time, I don't know, childhood. If you choose one element A, then it becomes phi A. So, and there is some arrow relating with this. This is phi. This is what you run at the childhood, but instead of this, in mathematical physics, you prefer to write this one because this is more nicer in the sense nicer in the sense that one thing is that you write directly phi is relating A1 set A1 to set A to set B. The other is that you are relating each element in A becomes phi A. So when you were young, you write something like x equals x 제곱. Sorry, 제곱 is Korean. X square. So this is good, but in fact this is bad because we don't know what is the domain. So set is, it can be just domain can be just integer, domain can be just a real number, domain can be just rational number, irrational number. So you should specify what is the set. So that's why we prefer this notation. The other is that this figure is nice, but drawing figure is, drawing figure and later is not that easy like just writing. So we will use this one. Okay, this is the notation I want to explain.